A big hello to everyone joining in this session from the ASSW conference and also from across the world. You're helping us to celebrate our 25th birthday, EPB's 25th birthday. I have the huge pleasure of welcoming you to our session here at the 2021 Arctic Science Summit Week. Our session is titled Europe in International Polar Research, 25 Years of Arctic and Antarctic Cooperation with the EPB. The EPB is an independent organization focused on major strategic priorities in the Arctic and Antarctic. Cooperation across the poles, across national and disciplinary boundaries have long been characteristics of the European polar research community. And that's conducive to its global leadership in research, both in the Arctic and Antarctic. In celebration of the EPB's 25th anniversary and continued collaboration with IASC and SCAR, this session will showcase world-leading bipolar European research and the impactful policy it has helped to shape. By fostering collaborations and connections between Arctic and Antarctic researchers across borders and disciplines, Europe has further cemented its leadership. This session will start off with exploring some of the large-scale leading research made possible by the international and interdisciplinary research environment nurtured in Europe. We will do this through invited keynote lectures dealing with topics ranging from ice, ecosystems, climate change, indigenous knowledge and social ecological systems, European infrastructure, and policymaking. After a short coffee break, we will follow up with an international collaborations and cooperation session, which is focused on the EPB, IASC, and SCAR, including a short virtual MOU signing between the three organizations. We will then continue into a short panel discussion, which will be moderated by EPB's chair, Kirsi Latola. The panel discussion will be looking at the next 25 years of European leadership in polar research. And we will bring together all of the EPB's action group chairs for this. Before we jump in, I have a few housekeeping remarks. This webinar is being recorded and it will be posted to the European Polar Board's YouTube page. A link for this will be provided in the chat box soon. We will also have a short report that we will prepare and post on the EPB website. The microphones and the cameras of the audience are automatically turned off. If you're having any problems, please use the chat box and ask us for assistance. We will try to help you. The full program for today is available both on the ASSW and on the EPB website, and we will share a link to that as well. As we go, if you have any questions on any of the presentations that are being made, you can ask them directly in the Q&A box. We will address what questions we can in the question and answer period after each presentation, or we will also ask the speakers to follow up after their talk is done. For this webinar, we will use the code of conduct that is being used for the overall ASSW 2021, and the link for that is also posted in the chat. With that, let's get started, and I'd like to introduce my colleague, Joseph Nolan, who will take us into the research highlights session. Joseph, please.
Yes, thank you very much, Renika, and welcome everybody to this session. In a slight rearrangement of the agenda, as we're still waiting for one or two speakers to arrive, we will instead begin with Pauline. So Pauline is going to present on from a permanently to a seasonally ice-covered ocean, expected ecosystem changes and knowledge gaps. So without further ado, I'll hand over to Pauline, please. You're on mute at the moment, Pauline.
I forgot to unmute myself. So we try again. So Can you see my screen? Yes. Okay. I will talk about the big change in the Arctic Ocean, where we are going to have a completely different ecosystem because the ice cover is going to be seasonal instead of permanent in the central Arctic Ocean. And here to the left, you see a photograph of the North Pole I took 20 years ago. And to the right, you see one that I took 2012. It was a warm year, but both are in the North Pole area. So you can even see the difference when you're up there. The Central Arctic Ocean ecosystem is defined by the Arctic Council, by the working group PAIM. And you see the yellow borders here on this map. And it essentially includes the central deep basin and the ridges. And this area was defined as the permanently ice-covered part of the Arctic Ocean. And in the Beaufort Sea, it is therefore along 76 degrees. The productivity of the Central Arctic Ocean, the area within these yellow borders, is extremely low. And there's a very nice recent paper from Nötig, and there they show all the chlorophyll and also particulate organic carbon measurements that have been made in the area. And you see, compared to Frem Strait and the northern Atlantic and the Barents Sea, you have very, very low productivity in the central part. And what they also found is that there is no trend with time in the last 25 years. So this has remained a very nutrient poor area. So the Central Arctic Ocean does not have a permanent ice cover anymore. And the red lines here in the two graphs to the right show the summer limit of the average ice cover in the late 90s and 2000s. And to the left, you see the winter ice cover as it was just 2 days ago, or a few days ago. So in the winter, we have, of course, a larger ice cover, but the area within the red lines, that was the permanently ice covered area 20 years ago. And the predictions say, the model predictions say that within 50 years, before 2050, we will have an ice-free North Pole every year. There is a difference between Antarctic and Arctic ice cover, and here I also refer to two very recent publications. There is a weak increasing trend in the Antarctic sea ice cover and a strong decreasing trend in the Arctic. And you see, I mean, you have seen this many times already. It's both in summer and winter. So the blue lines are the Arctic and the red lines are the Antarctic extent of the sea ice cover. There is one big difference. Well, there are many differences. They're opposite poles, and they have many things in common, but they are also opposite poles. And one thing is that the Antarctic sea ice is surrounded by ocean. So there's maximum connectivity with the marine ecosystem. On the other hand, we have in the Arctic that it is surrounded by land, and there is relatively low connectivity with the ocean, world ocean. Here you see also how the multi-year ice, the old ice, has changed over time. So the habitat of old ice, the ice that remains over several seasons, is decreasing a lot, and it is now mainly concentrated in the area north of Canada and Greenland. One path of connectivity between the marine ecosystem of the North Pacific and the North Atlantic is the inflows through the gateways. And the Atlantic inflow is the largest one. It is about 10 times larger in volume than the Pacific inflow. And then this forms the Atlantic water layer throughout the central Arctic Ocean. And you see the lines here that show the inflow and again also the outflow through Fram Strait. And you see also the other inflow region, which is through the Barents Sea. And these inflows, they carry Atlantic species to the central Arctic Ocean. And it seems that this habitat is also a suitable place for Atlantic organisms to live, at least some of them. And here you see, for example, the armhook squid and an amphipod that are Atlantic species that occur in this Atlantic layer. There is another type of connectivity between communities living in the Central Arctic Ocean, and this is around the edges mainly. It's the slopes. The slopes, they connect the Central Arctic Ocean with the shelf seas, and the slope communities all around the Central Arctic Ocean are connected in a circle around the deep basins. And this was also a recent publication, a very nice publication by Bodil Blom and colleagues. Then I am working for the European Commission in a project where we work with the question, if the summer sea ice decreases, are there any fisheries possible? So we would like to know how many fish do we have in this area, the Central Arctic Ocean. And first we did this gap analysis, which is made purely on scientific publications. And here you see, for example, if you want to do fish stock assessments, we know too little, that's this triangle, about the abundance of benthic fish, the abundance of pelagic fish, and biological fish data, that's ecological data. About the ecosystem, in general, we know quite a lot about oceanography, bottom topography, and ice cover dynamics, if you need to say something about the ecosystem. But we know very little about seasonality and almost nothing about food webs. So this graph shows where we found that the gaps are. And for example, fish data here, you see, we know very little about the Central Arctic Ocean. Also, we know little about the Kara Sea, the Laptev Sea, the East Siberian Seas, and the area north of Canada and Greenland. But we have quite good knowledge of the Barents Sea, which is one of the most productive seas in the world. And the fish has good management. The fish, there's a big fishery industry, so that is completely the opposite to the Central Arctic Ocean. When we then go on, how do we get those data? I mean, if the EU and of course many other actors want to know, will this be an area where fisheries are possible if it's going to be accessible for fishing vessels? Then we need to fill out all these red gaps. And some things are going on. Slowly the knowledge is growing, and these two European icebreakers, the Polarstern and the Oden, a German icebreaker and a Swedish icebreaker, they have collected much of the data we know today of when it comes to on-site research in the central part, because they are very strong icebreakers. And they are organizing big expeditions. The Odin is, for example, taking part in SAS, and the Mosaic has been a year-round expedition that ended last October. Here you see one of the fish, the only fish that we know occurs a lot in the Central Arctic Ocean. It is juveniles of the Polar Cod of Boreogadus. And here I have summarized what we know more. So we know that these juveniles are there. You can see them everywhere. But then we have only 3 records of ice cod, which is Arctogadus. And then I mean, I talk about a few hundred species, that individuals that they got up here with seismic blows, and here about 20 specimens that they caught with normal fishing lines just under the ice. Then there are 5 observations of arm hook squid at those yellow. And as you see, these are very much associated with the ridges. Then there are rare observations of benthic species, and even more rare observations from submarines, where the captain writes in the logbook, we saw a fish, but then we don't know which fish. And most of these observations, as you see, are also a long time ago. So we know very, very little about the fish in the Central Arctic Ocean. We get some first glimpse in this new study, and that was 13 acoustic stations in a transect from the Nansen Basin, the north of the Yermak Plateau, until deep in the Canada Basin. So this was made during the Odin expedition in 2016. And what we discovered was that there is a deep scattering layer. And we can measure that with acoustics. And these scattering layers, they consist of zooplankton and small fish. And these scattering layers occur in all other oceans. And now we know that it also occurs in the Central Arctic Ocean. Here you see scattering diagrams, and this is what I'm talking about. Between 300 and 600 meters of depth, we have this scattering layer. And at the North Pole, this is taken at the North Pole, we see that this layer consists of single tracks, and that suggests fish. But we cannot never be sure if we don't take any samples. Where is this scattering layer? How is it? What are the environmental conditions? Yes, it is confined to the Atlantic layer of the Central Arctic Ocean, and this has a temperature above 0, while the water below and above it is minus. So this is the habitat that these organisms live in. The conclusions from this study are that the Atlantic water layer is a habitat for pelagic fish, but we still don't know which species. The zooplankton in this layer provides food for these presumptive fish. If it is fish, we see, it could also be siphonophores, but if everything we see is fish, then there are maximally 2,000 small fish per square kilometer and about 50 kilograms per fish per square kilometer. And that is very, very little. And together with these observations, the productivity of the Central Arctic ecosystem is expected to remain low. There is some increased inflow to the Central Arctic because of climate change, but it can never support a large fish population that would provide a sustainable commercial fishery, at least not in this century. We cannot look further. So it's much better to fish in the shelf seas. They are closer and they have 100 times more fish. So what this area needs is protection, international protection. Another thing we try to find out is if it, since it's so difficult to catch fish there, you cannot troll. It's just a big methodological problem to get up fish. So we try to use DNA. So the question is, can we measure polar cod or other fish with, with metagenomic data that are taken, and we have quite a lot of metagenomic data already that we can use. So I had a data set from 2012, and we investigated this, and we could, in 63 out of 66 samples, we could, from the genes that are floating into the water, the fragments of DNA, we could identify which fish we have. And here it was polar cod, because we took it in the ice. That's where the juveniles live. I recommend you to listen, if you're interested in this, to Moritz Buck, who we work with, and he will present the latest results on which fish he has been identifying in the Central Arctic Ocean. Our project for the European Commission has to do with the agreement to prevent unregulated high seas fisheries in the Central Arctic Ocean. This agreement means that there will be no fishing for at least 16 years, and there will also be a joint program of scientific research and monitoring, which will be launched by the 10 signatories after China has ratified as well. So we're waiting for China, and then we can go out and do more research. So then my last slide shows that we will go out then on these 2 expeditions to the high seas. You see, it almost overlaps with the Central Arctic Ocean, but this is the area outside the exclusive economic zones of the coastal states. And what we are going to do is we are going to analyze which species we have. We will analyze this with eDNA, deep sea cameras, and fish samples. We will look at the distribution and biomass of fish, squids and their prey, and we will do that with hydroacoustics. Then we will study the ecology of the pelagic fish and squids in the high seas. And we will study the food web, migration patterns, etc., from fish samples. And in the end, we will draw conclusions about the carrying capacity of the high seas. And that means primary production, zooplankton, fish and squid, how much of it is there, and how much can the ecosystem support. And this will be new measurements and data compilation from the literature. So these are our plans for the near future. We go out this summer, and we actually have been out with Mosaic, and there are some results I couldn't tell you yet, but this means that our research adds to being able to work with this agreement. And also, as I already said to you, my expectation is that we will have to conclude that yes, there is fish, but there are very few of them in the Central Arctic Ocean. And that makes these fish that are there very important for the ecosystem, to keep a healthy ecosystem going. So thank you very much for listening.
Thank you very much, Pauline. Yes, we're actually getting a little bit ahead of our, or behind our schedule. So I would suggest if there are any questions for Pauline, they can go in the question and answer box, and Pauline can directly type answers in there. And maybe we'll have a little bit of time for some questions all together at the end of the presentations. But thank you very much, Pauline. We'll continue now. Unfortunately, Ruth Motrum is with a personal problem, is perhaps not likely to attend. So we'll continue with our revised program with Stas. So Stanislav Sinofonto, I'm sorry, Stas, for mispronouncing your name, who will be speaking on indigenous knowledge in the Arctic, and particularly in Yakutia, and the social ecological systems in the context of global change. And I have your slides ready for you, Stas. If you just give me a moment. Please, Stas.
Yeah, thank you, Joseph. And thank you, EPB, for having me. So, yeah, today I'm going to talk about the indigenous knowledge of Arctic Yakutia, social ecological system in the context of global change. So next slide, please. Yeah, I'm going to talk about social ecological systems, and particularly about Arctic social ecological systems and global change drivers and the impacts on Arctic social ecological systems. And I will talk about indigenous knowledge and case study in Arctic Yakutia. Next, please. Many Arctic communities are highly dependent on ecosystem services and goods for food, economy, as well as spiritual and cultural well-being. So Arctic communities have a very close relation to their natural environment through hunting, fishing, gathering, reindeer herding, cattle breeding, and beliefs. And this, next please. And these interdependent relations between humans and nature are called social ecological systems. So social ecological systems is a tiered approach to analyze the components and subcomponents of complex social ecological systems. And it has four main components. First is resource systems such as river, resource units such as fish, actors such as fishers or hunters, and governance systems such as fishing regulations. And these components interact in a specific social political setting and ecosystems to achieve certain outcomes. Next, please. And over the last decades, social ecological systems are significantly affected by global change direct and indirect drivers. Among direct drivers, global change, we can define land use change and technology adaptation. For example, mine excavation, roadways, heavy machinery. Another one is climate change, contamination by nutrients, nitrogen deposition, overexploitation, overhunting or overfishing, expansion of alien species. Among indirect drivers, we can define demographic, such as migration, economic or globalization, market, socio-political or regulations, laws, science and technology, culture and religion. Next, please. As a result of climate change, traditional food security of indigenous communities is challenged. Due to invasive species, native species may go extinct, or land use change may cause cultural loss. However, global change drivers may also open up opportunities for social ecological systems, such as better access to remote areas or economic benefits. In drivers indirect drivers such as population change, migration, for example, may result in a cultural loss. Socio-political factors may empower indigenous communities. Economic factors may increase the rate of resource consumption. Cultural factors may influence environmental stewardship or ethics. Technological change may cause species decline. Yeah, next, please. Sometimes it is quite difficult to assess remote areas in the Arctic, and therefore there is a lack of scientific literature on vulnerability of social ecological systems to global change. And in this case, indigenous knowledge can help to complement scientific records, although it is not a body of knowledge in its Western understanding, but rather a continuous cognitive process gained through practice. Therefore, it is important to incorporate traditional or indigenous and local knowledge and to engage northern and indigenous communities in setting priorities, co-designing and co-producing research, and to disseminate this knowledge by ensuring access to research data and results. Next, please. Indigenous knowledge may serve as an additional source of information, which can provide human perspective to scientific data. For example, indigenous communities may notice relations among winds, animal behavior, and ice conditions, which may not be easily explained by scientific data. For example, some researchers reported more holistic and integrated snow terminology of Sami reindeer herders brings different perspectives of snow in comparison to the international soil classifications. And over the last decades, indigenous knowledge received recognition as a useful indicator of Arctic environmental change. Indigenous cultures have an extensive knowledge base about ecosystems, which they transfer through communication from one generation to another. Next, please. And now I would like to share a case study from Arctic Yakutia, because it is crucial to understand the response of Arctic social ecological systems to global change, because as I mentioned, Arctic communities are highly dependent on ecosystems. Furthermore, Arctic social ecological systems are especially vulnerable to global change because climate change is more intense in the Arctic, and ecosystems are more susceptible to climate change effects, and livelihoods are more the poorest and more marginalized in the Arctic. Therefore, this research aims to understand the changes of social ecological systems as a result of global change, assess the vulnerability of social ecological systems of Arctic Yakutia, and finally examine the adaptive capacity of social ecological systems of Arctic Yakutia to global change. And due to time constraints, I would bring only a few examples of this research. Next, please. Yeah, next, please. So this case study was based on two case study areas which are located in 4 Arctic settlements, Chokurdakh and Olenigorsk in the Alayhovsky district, and Tiksi and Kyusur in the Belunsky district in the Republic of Sakha-Yakutia in northeastern Siberia, Russia. And these settlements are located in the delta of 2 large streams, Tiksi and Kyusur on the Lena and the Laptev Sea, and Chokurdakh and Olenigorsk on the Indigirka at the East Siberian Sea. Next, please. The indigenous ethnic composition of the region is different. Alayhovsky region mainly consists of Eveni and Sakha, and Belunsky district consists of Evenki and Sakha. So these are the 3 indigenous communities of the Republic of the Arctic region of the Republic of Sakha-Yakutia. Yeah, next please. So local people's perception regarding climate change in the region varies, but overall, local people agreed that winter temperature is rising and summer temperature is decreasing. For example, one of the interviews stated that over the last 10 years, it is warm in winter and cold in summer. In addition, the weather tends to be more unstable. The respondents also reported the early arrival of spring, causing the river ice to break up earlier. One of the respondents says, "I think seasons arrive earlier. It blooms earlier. For example, this time of a year," and the interview occurred in July, "we used to collect cloudberry. Blueberry used to grow in August, but now everything grows together." Next, please. So the table in this slide summarizes biodiversity change perceived by local people in the region. So one of the crucial consequences of climate warming is new species arriving in the tundra. South species expanding northwards, and over the last decades, the number of predators has significantly increased in the forest tundra. The sable was unobservable in the tundra before, and today it is abundant by the study sites. And people also observe new birds, which were uncommon for the area, and some interview participants even couldn't recall the names. And not only for birds, but also for plants and for some animals. Next, please. Increasing winter temperatures may be are good for indigenous people's survival in the harsh environments, but it has a negative effect on the fishing practices. For example, late river freeze up hinders winter fishing. Warm water regimes may affect fish abundance because fish physiology depends on temperature variations. And one of the participants stated that if the river is warm, fish goes down to the bottom. Therefore, it is difficult to catch it. Fluctuations in water levels affect the quality of fish and cause a decrease in the numbers of whitefish. Low water levels increase the number of parasites and associated problems. Next, please. In addition to climate change induced issues, Arctic communities are compromised by regulations. I was looking at fishers, so by fishing regulations. These regulations that were introduced after the collapse of the USSR presented the fishers with quotas, temporal limitations, and restrictions on size and type of fishing gear. Most of the participants voiced the opinion that fishing regulations and policies are problematic for them. Okay, next, please. The vulnerability of the indigenous and local people is increased due to recent climate and environmental changes. Even though the literature suggests that climate change is a slow and long-term process with a gradual impact, our findings demonstrate the opposite. Climatic change and effects seem to be more pronounced in the Yakutian Arctic. Environmental variabilities tend to be harsher when they interact with political, economic, and other institutions in negative ways. After the breakup of the Soviet Union, fish emerged as a very important food and income source for many people, since subsidies by the communist regime stopped supporting Arctic people. Okay, next please. To conclude this presentation, I would like to mention that Arctic social ecological systems are more vulnerable to global change drivers. Shocks like floods, trends like warming or social decline, and seasonality such as food insecurity challenge Arctic social ecological systems. And actors are vulnerable to both shocks, trends, seasonalities, and governance systems. However, a governance system is more compromising. Thank you very much.
Thank you very much, Stas. If anyone has questions for Stas, we can handle them through the Q&A box. I mean, I would have a question myself, if I can take the liberty to ask you, Stas, what would be your personal recommendations for how Indigenous knowledge can be better integrated within Western science and research?
Thank you for your question, Joseph. I would say that the best way to integrate knowledge is to take into account this knowledge and to involve in communities in co-creating research projects and to co-produce knowledge with communities. And so one of the best ways to integrate is to disseminate this knowledge to communities, because it is always good to communicate back all the results you gained with communities, because I heard many times, and I know myself, that researchers coming from Western world, Western countries, coming to communities using the infrastructure, let's say, and resources, but sometimes they do not communicate back these results, and people feel themselves as that they have been used but never have been communicated back. Yeah, that's, I think, the best way.
Thank you very much, Stas. So we'll continue with the program, and next we'll have Gonçalo Vieira from the University of Lisbon, who's going to talk about European polar infrastructure. So over to you, Gonçalo.
Hello, good afternoon. Joseph, can you see the full screen?
Yep, looks great.
Okay, perfect. Okay, thank you very much. First of all, I would like to take this opportunity also to welcome everybody to the Arctic Science Summit Week as one of the hosts. It's a pleasure and an honor also to have you here, a country that it's not traditionally involved in Arctic research, but a country which, of course, is interested about what is going on in the Arctic, and also to contribute to better understand the Arctic. Yeah, I'm a researcher. I'm a professor of physical geography at the University of Lisbon, but I also manage a small polar program, which was born in the IPY about 13 years ago, about that, which has been becoming more interested in both the Arctic and the Antarctic, and is also it's a program led by scientists, but which is growing, and hence I'm both a scientist and also, as the head of the Portuguese polar program, also involved in infrastructure. And today my talk relates to my linkage with the European Polar Board. I'm a member of the European Polar Board representing the Portuguese Science and Technology Foundation since about 2007, which means that I have been involved with the EPB for about half of its life, since we are celebrating now its 25th anniversary. And it has been quite interesting to be involved in the EPB. We have learned quite a bit with the EPB, and I think that Portugal, even though being a small nation involved in polar research, has also been able to contribute to the EPB. Well, those of you which are more into the European context will know quite well how complex Europe is. I have decided to start to talk with this map here, which shows, well, European from above, with the borders highlighted. But as you can see, it's a large number of countries, different sizes, which go from Northern Africa to the high latitudes to the Arctic, and it's a very complex continent, both geographically but also politically, as you know. The countries have, of course, very different perspectives. They have many of these countries. They have long-standing programs related to Arctic and Antarctic research, and the EPB. One of the roles of the EPB is to try to bring together the efforts of the individual nations, the individual European nations, and bring them together in order to better serve science and also European polar policy as a whole. And so, in the framework of this complex arena, Portugal plays a small role, but it also plays a role. And one of the reasons, or one of the consequences of this role, is also shown by the fact that we are now organizing the ASSW in Portugal. So the European Polar Board, which with its 25 years of history, has been bringing together European polar researchers, research policy, and also trying to pave the way to have a more coordinated policy relating to research infrastructure and to its promotion. And I'm going to present a bit about this. And I'm going to start with the Portuguese Polar Program. So we are a very small program. It is very peculiar that I'm presenting today on European polar infrastructure when Portugal is a country which has no polar infrastructure. But this also shows the richness and the wide possibilities that exist within the European arena, which shows that even a country which has no infrastructure can play a role in the coordination and in helping organizing European polar research. We have no infrastructure, but we have long-standing collaborations with different countries, and our polar program, as you will see tomorrow in the opening, has several activities going on both in the Arctic and in the Antarctic, but it's completely based on international collaboration. So we have quite a significant experience on international collaboration, both on sharing infrastructure, on making use of infrastructure from other partners, but also I was seeing something here popping up on the chat, but also on collaborating in science. So today we are here, quite far away from the poles, and I'm going to speak about European polar research infrastructure. Europe, in fact, is one of the major players globally when you bring up all the European countries together. And as you can see in these two maps, both from the Arctic and in the Antarctic, it's really overwhelming how widespread the European infrastructure is. This is the network of stations that we have been able, within an European project, EU PolarNet, where also the EPB is associated to identify. And we have identified 32 stations in the Arctic, 32 stations in Antarctica and the subantarctic islands. Europe has 2 icebreakers, 14 ice-strengthened research vessels, and also an aircraft fleet operating at both poles, mainly associated with the Alfred Wegener Institute and also with the British Antarctic Survey. So it's in fact, Europe has an incredible wide spatial relevance in what concerns to its presence in both polar regions, which means that it can really interconnect, and it has a very high added value in what concerns to polar research. Around 2007, the European Polar Consortium started to think about the European landscape of polar research in an integrated way. More recently, and especially in the last 3 or 4 years within the first EuPolarNet, we were able to really move a step forward in what concerns to coordinate the European polar research infrastructure and to try to align it with a new integrated European polar research program, which we are trying to implement in the framework of the new EC frameworks. So a couple of years ago, we organized the European Polar Infrastructures Catalog, and last year we published the white paper on European polar infrastructure access and interoperability. And I'm going to speak about this white paper and to highlight the main challenges associated to European polar infrastructure, and also what we think it's necessary to better tackle these challenges in a way that Europe can really maximize its efficiency and also improve collaboration, not only among European researchers, but also in the international realm. So the main challenges we have identified is that, well, as I told you, Europe is very complex. We have multiple national research programs which have their own priorities, but and each country, in fact, has also different types of policies concerning the polar regions. So for better tackling and better managing this infrastructure, we really need to account for the key characteristics of the programs, of the infrastructures, and also to respect the national interests of the different programs. But we also want to secure stronger research collaboration and also to foster new scientific impacts by bringing together this network of infrastructures. One of the goals is also to optimize operational costs, because as we all know, running polar infrastructure is incredibly expensive, but we want to make use of the network in order to minimize the costs of the operations, while also reducing the environmental footprint, also linking with the new European Green Deal, and making better use of the resources while affecting with a less impact the ecosystem. And of course, one of the ways to do this is also to reduce the overlaps and also the duplication of efforts, especially when we want to align logistics and the way that the field seasons are organized. And if we manage to do a more efficient use of the resources, this of course will lead to more harmonized actions, which will develop more balanced cross-disciplinary observations in science. We aim also at improving coordination, enabling better interaction with both industry and the private sector, as well as their engagement, boosting research and society interactions. So making use also of industry possibilities to foster research and observations, essentially relating, for instance, to monitoring, or also developing new systems for data acquisitions, etc. And we are also very much interested in improving the connectivity with global networks and systems, both in Europe and also beyond Europe. Of course, strengthening the sustainable infrastructure development and innovation. Europe, as in this plan, in this white paper on European infrastructure, has been essentially based on two cornerstones. One of these is transnational access, where Europe has already a tradition for some years now on making available European infrastructure with EC funding available both for European researchers but also for international researchers, in a way that we can really improve the outcomes by funding research also for external partners. So transnational access and sharing have been are one of the pillars of European polar research. But there is also, it has been identified that we need really to foster interoperability between systems, because many of these programs have developed separately, and it's really necessary to improve this interoperability in order to maximize the outcomes. And several items have been identified, and it is necessary to improve this interoperability in what concerns to the capacity of observations, instrumentation, operational protocols, data reusability, standardization, quality control, and also data encoding. And Europe, in fact, has been having some cases of success. In what concerns to transnational access, I'm not going to speak in detail about this. There was a world meeting today where several of these programs have been highlighted. But well, Interact is a flagship program of Europe for the terrestrial stations in the Arctic, which are giving the possibility to researchers across the world to access these high quality infrastructure. And I've been involved in Interact, in the Transnational Access Board, and it is very interesting to see how young researchers and early career researchers are really making use of these projects in order to access these regions. Then there is ARISE, the Arctic Researchers Icebreaker Consortium, Eurofleets, not only working in the polar regions, SIOS, as we have seen in the morning, but also some other examples which are not as integrated as what is going on in the Arctic, because the examples which I spoke about now are Arctic examples. In the Antarctic, the situation is quite different. Most of the relationships are bilateral relations between countries, and based essentially on bottom-up collaborations. And one of the issues that we have identified is also the need to extend this kind of projects of transnational access projects to Antarctica, but of course under a very different framework, since logistics in the Antarctic is quite different and also regulated under the Antarctic Treaty System. But we have the Concordia French-Italian access system in the Concordia station in the continent, and we also have very interesting modular approaches by the Dutch program together with the British Antarctic Survey. And finally, we would highlight also the action of COMNAP, especially in what concerns to a new group working on improving logistics in the Antarctic Peninsula region, where several European partners are also involved. But of course, it's not an exclusively European process. And just to wrap up and to finish, I would like to come back to the European Polar Board and to emphasize that I think that this is my personal vision, of course, and it's also associated to this white paper. But of course, the ideas which I'm expressing here also are a bit my own ideas, which are expressed in the talk. I think that the European Polar Board, it's really key to develop and implement implementing a model for interoperability, and also supporting this alignment of European and national policies. We have identified several sustainable development goals where a better operation in the polar regions can really be used essentially to decrease the impact of the footprint, and also to make the infrastructure future-proof. Now, finally, I would like, since well, I'm not going through the infrastructure white paper, I just presented some of the highlights. I would invite you to have a look at it and to learn more about it and what we are proposing to tackle and to better manage the European infrastructure and to coordinate it with the European Polar Research Program. And of course, I would have to ask to thank my co-authors, Nicole Bibao, David Velasquez, and the number of colleagues which have been working in the last couple of years together. Well, during the last year, it was more difficult due to the COVID-19 situation, but quite intensively in bringing up this infrastructure access and interoperability white paper, which I think it's quite relevant. So I would invite you to have a look at the European Polar Board website, and also to the EuPolarNet website, which is currently involved in this kind of activities in Europe. Thank you very much.
Thank you very much, Gonçalo, and particularly thank you because you're so busy with the running of ASSW to give up a bit of time to make this presentation for us. We don't seem to have any questions just at the moment, and in the interest of time, I think we'll continue. So thank you very much, Gonçalo. We now have Ruth has managed to join, so we will go back and we'll go back to Ruth in the program, and then we will go to Gosha at the end before the coffee break. So thank you very much, Ruth. It's Ruth Motrum from the Danish Meteorological Institute, who is going to be talking about the importance of ice in the polar environment. Ruth, please.
Great, thank you very much. And I do apologize for my lateness. I have a small family emergency going on, but it seems to be settling down now, so we're getting there. I'm going to try and share my screen, so do let me know if you can see this. Here we go. Yes, can you, hopefully you can see the presentation I prepared. So this is going to be quite a general presentation. I hope that's okay, and please do feel free to ask any questions afterwards. And I thought when I was asked to present about ice in the polar regions, it's a pretty broad topic, but my personal speciality is really the interaction between climate and cryosphere, and in particular the big ice sheets. And so that's what I'm going to focus on today. Let's see, can I get this to go? Next. Yes, here we go. So, but I guess the most important reason why we're interested in polar ice, it's quite obvious if you live in a sort of low-lying country like Denmark, which I do. This is a picture that the National Geographic produced some years ago, showing if all the ice melts, and that by all the ice they mean all of Greenland, all of Antarctica, all of the small glaciers, everything gone. And this is the sort of coastline of Europe that you see. And you can see that there's really not very much of Denmark left. There's not very much of the Netherlands or Belgium left, large parts of France. The Baltic is particularly affected too. And I don't think anybody really thinks that it's very likely that this is going to happen in our lifetimes, certainly not in less than many hundreds, if not thousands of years. It takes a really long time to melt polar ice. So I think it's important that we are very honest and open that we're not talking about enormous amounts of ice sheets contributing to the sea level rise that we'll see in our own lifetime. And of course, it's entirely possible that we will be able to deal with some, with the timescales that we have available, we'll be able to deal with some sea level rise by coastal management and engineering. And I'll come back to that a little bit later. What we're more interested in countries like Denmark is storm surges. This is a picture from a storm surge that happened a few years ago actually in Copenhagen, in the area. This is one of our villages, one of the sort of outlying old fishing villages. And you can see this is a temporary wall that has been erected to keep the water from coming out. And we spend a lot of time and energy at DMI perfecting storm surge models and being able to try and predict when these things are going to happen. And it turns out that we've got better and better at this. But of course, as the seas rise, these kind of very high impact events are going to become more common because you need less and less of an energetic event to get that storm surge. So I think it's very important to distinguish between a sort of average mean sea level and these kind of storm surge events, which can be very destructive, but can be forecast in much the same way we forecast the weather. When it comes to sea level rise, this is from the IPCC's special report on oceans and cryosphere. I think it's a really great figure because this actually shows sort of projections of sea level rise out to 2300. And there has been a tendency for these kind of curves to stop in 2100 because that's, you know, when the models are basically, a lot of the global models are stopping around about then. And of course, sea level rise doesn't just stop either. It takes a really long time for the system to come back into equilibrium. So we have to understand that the push we're giving global sea level rise now, or the melting of the polar ice caps that's happening now, is going to take a very long time to come back into equilibrium and to slow down and stop. And this sort of big wide uncertainty band you can see is mostly attributable to Antarctica, also Greenland. But when this is stopping in 2100, when we start to get out of here, out to this sort of area, it's really very unclear what kind of sea level rise we will be facing on the scale of 200 years. And 200 years sounds like, you know, so far in the future we don't need to think about it. But the oldest building in central Copenhagen is 900 years old. And it's still standing. So we have to start getting used to the idea that we are building cities right now that are going to be there for 1,000 years. And maybe we want to think about how we plan our infrastructure. When the SROC was in preparation, I was part of a paper, very nice paper by Tom Slater at the University of Leeds, where we compared the sea level rise projections from the 5th assessment report, the IPCC 5th assessment report, with the actual observed sea level rise from the cryosphere. And what we found was that when you look at these figures, the actual observed sea level rise, and admittedly, it's not a very long period. We don't have observations for such a long period as we might hope. It's tracking this upper level. And when you sort of filter it out by processes, you can start to see here we separated out by polar ice sheets, so Antarctica and Greenland. And then we looked at the dynamics of the ice sheet. So this is ice flow, carving of icebergs. And we looked at the surface mass balance. So this is surface precipitation, snowfall, and then melt and runoff. And when you separate it out, you can see that the black here is the estimated from the IMBI assessment. I'll come back to IMBI in a moment, what the sort of sea level rise contribution is from these processes. And then this is what the models were projecting, these colored bars. And so essentially it looks like there's a slight increase in Antarctic surface mass budget, but the big sort of joker in the pack, if you like, that gives us this kind of big uncertainty band is Antarctic dynamics. There's also some suggestion here that surface mass budget from Greenland has been overestimated in the model. So the models are actually not able to detect as much melting from Greenland has actually been observed over this period. And that, I think, is generally true, or was generally true. I think the current generation of models is actually much better at capturing this because they're much better at capturing the important processes, and I'll come back to that too. And it's very much this kind of area, Greenland surface mass balance, that my own personal research has focused on. So if anybody has any questions, do feel free to ask. But again, there's also some fairly broad uncertainty in terms of Greenland ice sheet dynamics. So how fast do we lose ice in Greenland by carving and ocean-driven processes? And then this is this very wide uncertainty band at the top. So this was the IMBI-2 assessment that I referred to. IMBI is ice sheet mass balance into comparison exercise. And this is really a very international effort led by Andy Shepherd at Leeds University. And here, and this was an update on a previous assessment that was carried out in 2012. And here you can see that this is just for Greenland. There was also an IMBI for Antarctica, but I was not involved in that. I was involved mostly in this. And here we've summed up the surface component. So again, snowfall, snow melt, and the dynamical component, which is this in the background, and then this darker blue is the total component. So this is, if you add these two curves up together, you get this kind of darker curve. And I think it's fair to emphasize that the surface component is coming largely from regional climate models, and then on top of that we have also various remote sensing data products that I think have actually really revolutionized the way we look at the polar ice sheets. When I was starting out as a glaciologist in the sort of early 2000s, late 90s, early 2000s, the consensus was that these ice sheets were really, really stable. And then suddenly we started to observe, thanks to remote sensing data products, that actually this wasn't the case, and there were large amounts of ice being lost to the oceans. And that's really, I showed this plot to some students a few weeks ago. This is ice sheet velocity over Greenland from the Sentinel satellites. And it's actually amazing to me that in the last 20 years, we've developed this capability where we can actually measure how quickly the ice sheets are moving on a more or less weekly basis. Whereas, you know, in the late 90s, it would take many, many scenes and many different satellites to get this kind of coverage. So we've really got a huge amount of data. And one of the challenges I see now for scientists, European scientists or internationally, is we've got so much data. How do we process it efficiently? And how do we get the kind of insights that we can get out of them? And so ESA put together this very nice climate change initiative, and this is another plot. This is actually GRACE data from the gravimetry satellite and then GRACE follow-on. And really, these are actually able to measure using satellites where the ice is being lost in Greenland. And this is two different processing algorithms based on the same data, and they basically show the same thing. There's a small, potentially positive increase in the center of the ice sheet, and around the edge, Greenland is really losing a lot of mass. And that's more or less what you'd expect given our current climate system. I want to talk a little bit about what these different components actually mean. So this is a great figure. I see that Valerie Masson-Delmotte, she made a brilliant, her chapter of the fifth assessment report made this brilliant figure, and I use it a lot because I think it's one of the best illustrations of how an ice sheet actually works in the climate system. So here we have our model ice sheet. We have snowfall at the top, and it sort of flows out to the sides like kind of syrup. We have melt, we have all sorts of other interactions going on here. We have dust being deposited on the ice sheet or melting out. We have sunshine, we have melts going on and runoff. And this side, which is more symbolizing what's going on in Antarctica, we have calving processes. And so we have to really understand all of these processes to be able to make any kind of projections about how these ice sheets are going to change in the future. And we can divide these processes up, as I've said, between the dynamics, which is kind of this bit here, ice sheet discharge and calving, and surface mass budget. And the SMB, surface mass balance or budget, you know, in the last 10, 20 years, we've really spent a lot of time trying to get this right, because SMB is really the only way by which an ice sheet can accumulate mass. It can get snowfall and it can grow, or it can melt and run off, and that loses ice. But snowfall is really the key kind of builder of ice sheets here. All of these kind of processes, they're reasonably well understood on a physical level. They're not terribly well observed, though we do have some brilliant measurements. Our colleagues at GAIAS who run the PROMICE network, for example, they have very nice observations on the ice sheet. And I really wish we had more of those kind of observations to be able to evaluate if the models are actually working or not. So I've sort of already alluded to it, but snowflakes are super important. Without snow, we have no ice sheets. But measuring them is really hard. Anybody who's ever tried to set up a precipitation station knows that you miss half of your snowflakes, basically. You can go out and you can get snow cores, but generally they're quite tough. So we tend to use models to try and estimate how much snow is falling, and how much snow is falling is important because it then tells us something about, you know, how bright is the ice sheet, how reflective, how much melt is going to go on. We have this nice data set, which again is available from PROMICE at GAIAS. And here we've compared them with 3 different regional climate models, HAM5, which is the one that I run, MAR, which is this one down here, and RACMO. And you can see that there's some pretty consistent biases here. So here HAM and RACMO are dropping a little bit too much snow close to the margins, but they're getting closer further back to where we would expect them to be. MAR has got sort of the opposite bias. It's dropping about right down by the margin, but it's overestimating higher up. And this is really about the different types of models that are involved. But this has a consequence. If you're running an ice sheet model and you're trying to, you know, get the flow of the ice correct, you really need to have your surface forcing correct, because the ice flows from where you've got lots of snow out to the edges. And so within the ESA Climate Change Initiative, one of the things we've tried to do is look at, can we improve models by looking at radar altimetry? And here you can see the altimetry at the top, you can see the model at the bottom. And we get some of it right. So you can see that most of the melt is happening around the edges, which is good. That's what you'd expect. We seem to be underestimating inside the middle of the ice sheet. This seems to be very consistent between models. And this is a fairly consistent picture. And I think it's important here to distinguish between Greenland and Antarctica. Greenland is melting around the edges quite a lot. Here in Antarctica, you can see the same kind of altimetry. So radar that's measuring the change in elevation of the ice sheet. The really big changes are here around the edges, and they're not driven by melt, they're driven by ice dynamics, by how quickly is the ice flowing into the ocean and calving and breaking up or being melted by the ocean. And so I think it's really important when we're thinking about ice sheets and sea level rise to distinguish between these two ice sheets. The processes that are important are quite different to understand there, but you need to understand both. Although I would say ice dynamics is the most important thing to understand in Antarctica in terms of where ice is being lost, it's also important to understand that we don't necessarily know where ice is being gained either. So this is a study, it's just been accepted, that I've been involved with, where we've taken results from different models. We have HERHAM at the top, Cosmos CLM from Belgium, RACMO from the Netherlands, MARV also from Belgium, and METUM from the UK. And these are all regional climate models. They've all been forced on the boundaries with the same model, but they are run at different resolutions. They have slightly different physics in there. And although they have, on average, a fairly similar surface mass balance, they agree within about 10% how much snow falls on Antarctica and how much is melted or sublimated away. The spatial variability between these models is actually quite high. And you can see here, MAR, for example, gets much more snowfall here over the Ross Ice Shelf. Here, HAM has much more over the Filchny-Ronny than the average. Cosmos CLM is a bit dry in West Antarctica. So they're really important, and these again matter if you're trying to run an ice sheet model. So they broadly agree, but there's this spatial variability. And when we try and assess, you know, which model gets it right, we actually find it really hard to do. I'm not sure if you can see this. This is all the observations we have here, surface mass budget observations. It's actually not very many at all. We have very few observations that are reliable, and we don't have long time series of observations, which we really need to be able to assess how these models are performing. So there's actually a lot of work to be done just understanding where snow falls and how much falls and how often in Antarctica. So this is a problem that we really need to focus on in the future. Turning more towards models, one of the possibilities we have is to look at reanalysis. This is, I'm really excited about this. I've been sort of involved in this project since the start, but very peripherally. Most of the work has been done by my colleagues at DMI and across the Nordic region, in fact. Also Meteo France are involved in this project. It's a very high resolution climate reanalysis. It focuses on the European Arctic. We've taken as many observations as we possibly can and assimilated them into it. And this is now freely available in the Climate Data Store. It's a Copernicus data project. And I think that this is really a way that we're going to start being able to better handle these kind of very important questions, like how much snow is falling, where is it falling? It's by running these very high resolution models that have been optimized for polar regional climates. It's a very specialized and very difficult thing to do, and so we have to get better at using our existing competencies. And in the case of the Copernicus Arctic reanalysis, this is the weather forecast domain that DMI uses with the Icelandic Met Office, and this is the domain that Met Norway uses for Rome Arctic. So there's a lot of experience already gone into developing these weather forecasting models, and we can really use that in the climate and cryosphere kind of nexus. I guess the important thing to discuss really when it comes to sea level rise is what's going to happen in the future. This is just Greenland. I could also show something from Antarctica, but this is from the ISMIP-6 project, which was an ice sheet model into comparison. Really exciting project, and really I wouldn't say it's the first, but one of the best, most systematic ways that people have tried to look into this problem of sea level rise into the future. We didn't have very many GCMs to pick from in this project, so because relatively few of them were ready at the time, but so these were the ones that were chosen to provide forcing for a number of different models. And you can see that we get quite a spread in surface mass budget anomaly and in ice mass change forced by these different SMBs. So I think it's fair to say that when it comes to future sea level rise, there's still a very wide spread, and we need to get much better at narrowing that spread in the future to be able to make sensible decisions, or at least handling risk. Unfortunately, we have a new project called Protect, which is a new Horizon 2020 project. It's just started this year, or last year. And I think one of the important things to emphasize about Protect is, although we're very much focused on the cryosphere and sea level change, it's PEA is Gail Durand at Grenoble University. It covers a lot of different European institutions. and we're looking at both ice sheets and glaciers, the point here is that we also have a very strong component of dialogue with stakeholders. So how do we get better at communicating the risks of sea level rise? What are the actual kind of scientific results that we can present that are useful? Because it turns out that a lot of people have a 10 or 20 year timescale. They don't necessarily have a 100-year or 200-year timescale. So we have to really get better at working together between scientists and people within partner institutions and governments to really prepare for the sort of sea level rise that we know is already baked in, and how do we deal with that in the future. I think that's it. I hope I haven't gone too much over time. Just to say we've made some really big advances, and there's lots of things that we still need to do even so, and especially we need more observational data, and we need to get better at incorporating that into models to make future projections. And yeah, that's it. Thanks very much.
Thank you so much, Ruth. And thank you for managing to make it in the end. We've had quite a bit of mayhem going on, but that's okay. In the interest of time, I think we'll continue to the next presentation just before the break. There is a question in the Q&A box, Ruth, so maybe you can answer that with by type. So let's continue to our final presentation in this this first part, which is from Gosha Schmizek, who's from the Arctic University of Norway, who's going to be speaking on from polar science to policy making, taking stock and moving forward. So Gosha, over to you.
Great. Thank you very much, Joseph, and welcome everyone. Good afternoon, good morning, I guess. Well, I guess we have audience spread all over the world. And just let me start sharing the screen. Just briefly, can you see the screen now? Yeah, okay. So, well, two things. First of all, I was thinking, well, we are indeed a little bit behind the time, and I was thinking, well, it is great since I'm going to talk about policy and politics, and this is actually the last thing that keeps everyone now from coffee break. It is kind of, well, usually the hard spot where sometimes this question ends up. But of course, I think everybody agrees that this connection is very, very important. And we have actually, I mean, the occasion of EPB 25th anniversary. Yeah, it's kind of is a good place to kind of to reflect on some of the things. And I think many presentations that we've seen today, they were actually, well, kind of pointing in this direction, of course, on the critical role of science in addressing most critical problems that we are experiencing in the world today. And of course, they start from climate change, but we could mention as well biodiversity loss, sustainable food systems, you name it. And of course, the point is that as much as there is a very widespread agreement that policy decisions to address those challenges need to be informed by the best available scientific evidence, the problem oftentimes is that it is easier said than done. And the main reason behind this is that science and policy ultimately represent two very different universes. So in a sense, each of these worlds has its own sets of values, priorities, very, very different timelines, but also standards for accountability. So of course, the question that we keep on coming back to over and over again is how they can work together in the best way. And then one other thing that I was very pleased with all the presentations when I got the invitation to join this panel, there was the question, well, if you can also cover both poles, ideally within 10 minutes, I was like, okay, great, let us see. But I see that also other speakers were in the same position in many ways. So the question with Arctic and Antarctic is that, of course, there are, as much as there are certain similarities between the two regions, and there are actually some scientists who work in both poles, there are, of course, also fundamental differences between those two. And the same thing could be said about their legal regimes. And also what follows from there is the science policy interface. So I'm going to start here just very briefly with the Antarctic, because it's also the continent, it's also the pole for which the governance arrangements are historically much older. So one thing that is very important for everyone to know is that Antarctic Treaty System, or the system that we have for the governance of the Antarctic, is truly unique across the entire international environmental governance. And this is actually the arrangement that originated already in 1961. And it is based on the legally binding Antarctic Treaty and the legal agreements that were subsequently developed over time to address different issues in the Antarctic region. Here, of course, the stress is on the fact that this is legally binding regime for all the parties, which makes decision-making procedures much more straightforward than it is the case in many other parts of the world. When it comes to many arrangements applicable to the Antarctic, Madrid Protocol that was signed in 1991 and entered into force in 1998 is perhaps particularly worth mentioning. So Madrid Protocol is one name, but it's the Protocol on Environmental Protection to the Antarctic Treaty, because that was the protocol that basically designated Antarctica as a natural reserve devoted to peace and science. So this role of science in the Antarctic Treaty System really cannot be overestimated, because by far it is the system where the obligation to follow science and to pursue international scientific collaboration is at the very core of the whole regime. And not only that, it is one other element that is worth remembering when thinking about ATS, that this is also the region, the system committed to conservation rather than sustainable development, as is the case in the Arctic and in many other parts of the world. So of course, that's also something there to consider. Ultimately, when it comes to science policy interface in the Antarctic region, we can say that this is relatively or quite well structured and close connection we see there between scientific community and decision makers. And of course, here the key role is played by SCAR, Scientific Committee on Antarctic Research, which is the body of International Council for Science, and that informs, well, on the one hand, it coordinates the scientific research in the region, but it also provides independent scientific advice to decision makers in the ATCM. And the reason why I put in bold here decision is, as you will see in a moment, in case of the Arctic, in the Antarctic Treaty System, ATCM is actually the body that issues actual regulations and decisions that are legally binding for all the members to the treaty. And in many ways, the emblem of the Antarctic Treaty is really reflective of this system that is very, very centralized when it comes to science policy interface, but also in terms of decisions that aim at environmental protection and management of the Antarctic. That said, this picture probably could not be more different than what you see on the opposite pole. And of course, you surely know most of the logos here. And of course, this picture is very, very far from complete. We could add many more. But the point here is that in the Arctic, we have a plethora of both science and policy organizations. So oftentimes, of course, we hear about the Arctic Council, especially over the last 10 years. We've seen in the slide IASC, we've seen European Polar Board. Of course, we have also plenty of national scientific bodies, and of course, well, members of EPB are here the primary example. But what is very important to remember is that in the Arctic, when it comes to science policy interface, there is no single legally binding mechanism. So in a sense, there is no single channel where the relevant scientific information and evidence could be put into to inform the decisions. As you've seen in the previous slide, and I'm just going back here, there are various international and oftentimes global instruments that are relevant to the Arctic. We can be looking at UNCLOS, we could be looking at the UNFCCC for climate change, Minamata Convention on Mercury, CBD for biodiversity, etc. All those arrangements are very important or of critical importance to the Arctic. And the point is they all have their own science policy mechanisms. So that's one of the things to remember. Another thing, and that was of course already highlighted, is the question of great diversity of actors, right holders, and stakeholders in the Arctic. So something very opposite to the Antarctic is of course the question for the diversity of interest that needs to be accounted for when seeking to design policies to address Arctic challenges. Of course, and we've heard about this already from Stas, one of the unique assets and gems of the Arctic is indigenous knowledge, is indigenous and traditional knowledge. So knowledge systems other than science that are also critically important to inform these processes. That said, as much as the picture is incredibly complicated and we see all those different forests to engage with, there are also histories of success from the Arctic. And some of the examples could include persistent organic pollutants and the information from the Arctic that informed negotiations and completion of the Stockholm Convention, Minamata in case of mercury, and climate change. And climate change I'm using here as an example, of course, not of the challenge that we addressed effectively, but rather as something that was effectively put on the agenda of decision makers. So to go here quite quickly, when it comes to, some of you might know well the paper by Kevin Hughes and others from 2018, where they actually listed certain challenges that they've seen in the science policy interface in the Antarctic. But actually, if you look at this list, if you look at this slide, the thing is that those challenges actually characterize science policy interface, not only in both poles, but even globally. And among others, one of the basic challenges for the scientific community is oftentimes gaps that we still have in our knowledge and understanding of ongoing processes, uncertainties, consequences of those things that we don't know, and how to inform about this. So in a sense, of course, decision makers, they aim to base their policies rather on the best available evidence and not rather on the best available gaps in our understanding. But of course, there is also two other points to note here is the question that, well, the challenge of interdisciplinarity is of course very familiar to many of us, but the point is that integrating evidence from different disciplines actually very much enhances the reliability of evidence of the proof that can be delivered to decision making. So that's another argument to engage in those. When it comes to international collaboration, one thing especially relevant for both poles is that there is no single country that is likely to have resources and expertise on every single matter that we need to address moving forward. So of course, the imperative of collaborating across nations is very high here on the agenda. So which way do we go from here, especially with this complicated situation in case of the Arctic? I mean, so my background is in political science, and actually, well, I do study effectiveness of international environmental governance and in my research, but oftentimes in discussions around science policy interface is this question of what do you mean by effectiveness? And sometimes it appears that for some of us in the scientific community, effectiveness ultimately means pretty much as if science was to dictate what the policies should be saying, which is really very far from the reality, where policymaking process oftentimes, well, science is there to inform decisions in the best possible way. But of course, the question of values, of norms, they're all, and other interests are all to be accounted for. So it's kind of, so a different way to say is also to manage your expectations. what do you mean by effective science policy interface? But even more importantly is the question of knowing your decision makers. So as we've seen with other presentations, I mean, there is this question of what do you do your research on and who is actually the right recipient of your information. Sometimes it seems that the answer to this is not very clear, but oftentimes, well, we focus our attention on the international fora, whereas perhaps more suitable decision makers are the ones on the national and local levels. That said, of course, different ways of communicating to different groups. One thing that I wanted to point out here was the study from 2017 completed by Arctic, where they actually noted the importance of gray literature as particularly important when it comes to communicating with practitioners. I mean, no surprise, they are not necessarily the ones following all the scientific literature. But that's kind of something where, and I will come back to this in the last slide, it is something where teamwork and work in projects can be extremely helpful. And finally, on that slide, it's just one thing to highlight here is not to underestimate the power of putting things on the agenda, but also the challenge of sustaining them there. So there is this question, of course, well, of our attention span and attention span of policymakers in terms of following on issues. So this is definitely something that needs to be kept in mind. But as we are, getting just now to a coffee break, few things to put here in brief. I think one of the important things is to keep certain perspectives. So in a sense, to realize that actually over the last decade, we are doing much better in terms of delivering science and communicating science to policymakers. As much as it's sometimes not clear from the news or even the state of our planet, the thing is that we have today more collaboration and coordination than ever previously. At the same time, of course, the point is that we also have more fora, more actors involved. So this kind of, this challenge is how do we keep on collaborating and coordinating is ever present. Relationships are here, of course, key, and building them takes time. So of course, I think, well, when speaking to this forum, I mean, for all of us involved in this questions for several years, we are all very well aware of this, but this is something that needs to be truly carried forward. One thing, and here is the shout out that science policy interface is a really team effort and team sport. So in a sense, as mentioned previously, this race is really long. So even in case of the Antarctic Treaty System, where you've seen this very close connection between science and policy, actually, in order to take decisions, it may be easily few years before the thing is put on the agenda and before you see any results. So it's definitely something to tackle together rather than separately. And yes, just as we are coming close to the end, I think it is always worth remembering that there are already institutions and actors who have a lot of expertise and experience in connecting with policymakers rather than trying to seek our own ways. So I guess I could just conclude here by saying that when in loss, you could, for instance, reach out to European Polar Board. And with this, yes, happy anniversary. And I guess we came to the end. Thank you.
Thank you very much, Gosia. I think that nicely kind of wrapped up a lot of the ideas from the earlier presentations, and it kind of came to a bit of a confluence in that talk there. We are now deep into what was supposed to be the break time. So I suggest any questions for Gosia or for any of the other speakers, they can be in the Q&A box, and the speakers can tackle those as they come in throughout the rest of the session. So that concludes part one of our session, and we now have what's left of the break until 5 o'clock GMT, so just over 15 minutes until we'll restart. And in that second half, we will be hearing from the EPB, from SCAR, and from IASC before we have a panel discussion. But you won't hear any more from me, so yes, enjoy your break, and see you in a few minutes. And thank you very much to all the speakers. It was great.